Today we have to discuss about the manufacturing process. So manufacturing process is very important in manufacturing field. So first one is casting process, metal casting process. So metal casting process is one of the important process in manufacturing field. So metal casting process is virtually nothing more turns rules or flies without the benefit of cast metal product. The metal casting industry play a role in all the major sector of our economy. There are casting in cars, truck, aircraft, buildings, etc. The metal casting is one of the oldest material shaping methods. Known casting means pouring metals, so metal into a mold with a cavity of the shape to be made and allowing it to solidify. When solidified, the desired metal object is taken out from the mold, either the breaking the mold or taking the mold part. The solidified object is called the casting. By this process, intact part can be given strength and rigidity frequently not obtainable by any other manufacturing process. The mold into which the metal is poured is made of some heat resisting material. Sand is most often used as it resists the high temperature of the molten metal. Permanent mold of metal can also be used to cast products. So metal casting is one of the oldest material shaping method. Known as casting means pouring molten metal into a mold with a cavity of the shape to be made and allowing it to solidify. When solidified, the desired metal object is taken out from the mold either by breaking the mold or taking the mold up here. The solidified object is called the casting. So by this process, interact parts can be given strength and rigidity frequency and obtainable by any other manufacturing process. So metal casting advantages is it's extremely used in manufacturing because of its many advantages. So molten material can flow into very small sections so that intact shape can be made by this process. As a result, many other operations such as machining, forging and welding can be minimized or eliminated. It is possible to cast practically any material, that is ferrous or non-ferrous, as the metal can be placed externally where it is required. Large saving in weight can be achieved. The necessary tools required for casting molds are very simple and inexpensive. As a result, for production of a small lot, it is the ideal process. There are certain parts made from metals and alloy that can only be processed this way. Size and weight of the product is not a limitation for the casting process. So disadvantages is dimensional accuracy and surface finish of the casting made by sand casting process are a limitation to this technique. So many new casting processes have been developed which can take into construction. The aspect of dimensional accuracy and surface finish, some of these processes are die casting process. So investment casting process, vacuum sealed molding process and shell molding process. Metal casting process is a labor intensive process So common used for the making a mold cavity. So initially a suitable size of mold box for creating suitable wall thickness is selected for a two-piece pattern. Sufficient care should also be taken in such that since that the molding box must adjust mold cavity riser and the gating systems. It's been runners and gates, etc. So next, place the drag portion of the pattern with the parting surface down on the bottom. The facing sand is then springed carefully around the pattern so that the pattern does not stick with the molding sand during the top of the pattern. The track is then filled with the loose prepared molding sand and ramming of the molding sand is done uniformly in the molding box around the pattern. Fill the molding sand once again and then perform remaining. Repeat the process. Therefore, the excess amount of sand is then removed using stick of bar to bring molding sand at the small level of the molding flash height to complete the drag. Drag is then rolled over the parting sand is sprinkled over on the top of the drag. Now the cope pattern is placed on the drag pattern and alignment is done using dowel pins. The flask is placed over the rammed drag and the parting sand is sprinkled all around the cope pattern. Pure and razor pin are placed in vertically position at suitable locations using support of molding sand. It will help to form suitable sized cavity for the puring mold metal. So wrap and remove both the cope and drag pattern and repair the mold suitably is needed and dressing is applied. The gate is then cut connecting the lower base of square basin with the runner and then the mold cavity. Apply mold coating with a sweep and back the mold in case of dry sand mold. Set the core in the mold if needed and close the mold by inverting cope over drag. The cope is then clamped with drag and the mold is ready for curing. So what is the flask and patterns? So flask means a metal or wood frame without fixed top or bottom in which the mold is formed depending upon the positions of the flask in the molding structure. It is referred by various names such as drag, lower molding flask, cope, upper molding flask, check, intermediate molding flask, used three-piece molding. So pattern means it is the replace of the final object to be made. The mold cavity is made with the help of pattern. Parting line. This is the dividing line between the two molding flasks that make up the mold. So molding sand means sand which binds strongly without losing its permeability to air or gases. It is a mixture of silica sand, clay and moisture in appropriate proportions. Facing sand. The small amount of carbon metal sprinkled on the inner surface of the mold cavity to give better surface finish to the casting. 4. A separate part of the mold made of sand and generally bagged which is used to create opening and various shaped cavities in the casting. And puring basin. The small funnel shaped cavity at the top of the mold into which the molten metal is poured. Runner. The channel through which the molten metal is carried from the were to the gate. Then gate mean a channel through which the molded metal enter the mold cavity. Riser, a column of molten metal placed in the mold to feed the casting as it sinks and solidifies, as known as feed head. Pattern. A pattern is a molten or the replace of the object. It is embedded in molding sand and suitable ramming of molding sand around the pattern is made. The pattern is then withdrawn for generating cavity in molding sand. Thus, it is a mold forming tool. Pattern can be said as a model or the replace of the object to be the cast expert for the various elements. The pattern exactly resembles the casting to made. It may be defined as a model or form around which sand is packed to give rise to a cavity known as mold cavity, in which when molten metal is pure, the result is the cast object when this mold or cavity is filled with molten metal. So molten metal solidifies and produces a casting product. The objectives of a pattern. So pattern preparations is very important in casting process. So pattern purpose or mold cavity for the purpose of making a casting. So patterns process for print which produce set in form of extra rises for the core placement in the mold. It establishes the parting line and parting surface in the mold. Runner and gates or riser may form a part of the pattern. So properly constructed patterns minimize the overall cost of the castings. Pattern may be helped in establishing locating pin on the mold and therefore on the casting with a purpose to check the casting dimensions. So properly made pattern having finished and smooth surface reduce casting defects. So patterns are generally made in the pattern making shop. Proper constructions of pattern and its material may reduce overall cost of the casting. So common pattern material. Common pattern materials, so like wood. Wood is the most popular and commonly used material for pattern making. It is shaped as actually available is options repairable and easily fabricated in various forms using resin and glasses. It is very light and can produce highly smooth surface. Wood can preserve its surface by application of a shells. So advantage of wooden patterns. Wood can be easily worked. It is light in weight. It is easily available. It is very cheap. It is easy to join. It can be easily repaired. Wooden laminated patterns are strong. So the disadvantages is it is susceptible to moisture. It tends to wears out quickly due to sand abrasion. It is weaker than metallic patterns. So metallic patterns are preferred when the number of casting required is large and going to justify their use. These patterns are not much affected by moisture as wooden pattern. The wear and tear of this pattern is very less and hence possess longer life. Moreover, metal is easier to shape the pattern with good precision. So surface finish and is shape. It can withstand against corrosion and handling for longer period. Cast iron piece, so it is shaped stronger, tough and durable and can produce a smooth surface finish. It is also possesses good resistance to sand abrasions. The drawback of cast iron parts are that the hard, heavy and brittle and get resisted easily in presence of moisture. So advantages is it is cheap, it is easy to fill and fit, it is strong, it has good resistance against sand abrasions, good surface finish. So disadvantages is it is heavy, it is brittle and hence it can be easily broken, it may resist. So aluminum alloy patterns. So aluminum alloy patterns are more popular and best among all the metallic patterns because of their high lightness and good surface finish, low melting point and good strength. These also possess good resistance to corrosion and abrasion by sand and thereby longer life of patterns. These materials do not withstand against rough handling. They have poor repair ability and they are preferred to marking large castings. So advantages: aluminum alloy pattern does not rust. They are easy to cast. They are light in weight. They can be easily machined. So plastic are getting more popularity nowadays because of patterns and made of these material are lighter, stronger, moisture and wear resistance, non-sticky to molding sand, durable and they are not affected by the moisture of the molding sand. Moreover, they impart very smooth surface finish on the pattern surface. These materials are somewhat fairly less resistant to sudden loading and their section may need metal reinforcement. The plastic is used for this purpose are the masking resins. Plastic are commonly used. These are originally in liquid form and get solidified when heated to a specified temperature. To prepare a plastic pattern, a mold into halves is prepared in plaster of Paris with the help of a wooden pattern known as master pattern. Wax patterns made from wax are excellent for investment casting process. The material used or plant of several types of waxes or other additive which act as polymerizing agents. Stabilizer is the commonly used wax or pattern wax and microcrystalline wax. The properties desire a good wax pattern include low ash content of to 0.05%. Resistance to the primary coat material used for investment, high tensile strength and hardness and sustainable weld strength. General practice of making wax pattern is to inject liquid or semi-liquid wax into a split die. Solid injection is also used to avoid shrinkage and for better strength. Wax use help in impairing a high degree of surface finish and dimensional accuracy castings. So wax patterns are prepared by pouring heated wax into split mold or a pair of dies. The dies, after having been cooled down, are parted off. So advantages of wooden patterns. Wooden can be easily worked, so it is light in weight, etc. etc. So types of patterns. So various types of patterns is there. One piece or solid pattern, two piece or split pattern, then cope and track pattern, then three piece or multi-piece patterns, then loose piece patterns, then match plate pattern, then gate pattern, then slip pattern, skeleton pattern, segmental or part patterns, etc. So single piece pattern or solid working pattern is solid pattern is made of single piece without joint, parting, lines or loose piece. It is the simplest form of the pattern. So typical single piece patterns, two piece or split patterns. When solid patterns is difficult from withdraw from the mold cavity, then solid pattern is splitted in two parts. Split pattern is made in two pieces which are joined at the parting line by means of dual pins. The splitting and the parting lines done to facilitate the withdrawal of the pattern. A typical example is drag pattern. In this case, hook and drag part of the mold are prepared separately. This is done when the complete mold is too heavy to be handled by one operator. The pattern is made of two halves which are molded on different plates. The typical example of match plate pattern is very difficult methods. And three piece pattern. So some patterns are of complicated kind in shape and hence cannot be made in one or two pieces because of difficulty in withdrawing the pattern. Therefore, the pattern are made in either three pieces or in multi pieces. Multi molding flask are needed to make mold from this pattern. The pattern can also be seen from the mold cavity. And loose piece patterns. A single piece are made to have loose piece in easy to allow withdrawal from the mold. The molding process are completed after the main pattern is withdrawn, leaving from that piece in the sand. After the withdrawal of piece from mold, it cavity separately formed by the pattern. A loose piece patterns is highly skilled job and expensive. The next one, match plate patterns. The match plate pattern types is having two parts, one for one side and another one for another side of pattern. It is called match plate pattern. The sand casting pattern making in two pieces. It also having gates and a runner attached with pattern. The molding process completed after that match plate. Removed together the getting in obtained for joining the cope and track. Its pattern is mainly used for casting of metal, usually aluminum, or machined in this method with light weather and machinability. It should be possible for mass productions of small casting with high dimensional accuracy. They are also used for machine molding. The cast will be high of molding, but it is easily commensurate by the high rate for production and more accuracy. The pattern can also be seen as very difficult. The next one, gated patterns. In this pattern, mass production of casting multi-cavity mold are used. Such as molds are formed by joining a number of patterns or gates or providing a common runner for the molten metal. These patterns are made in metals and metallic pieces are from gates and runners are attached to the pattern. Sweep pattern. So sweep patterns are used for forming large circular mold of symmetric kind by revolving a sweep attached to the spindle. Actually, a sweep is a template of wood or metal and is attached to the spindle at one edge, and the other edge has contour depending upon the desired shape of the mold. End is attached to the stack of metal in the center of the mold. Skeleton pattern. So when only a small number of larger and heavy casting are to be made, it is not economical to make a solid pattern. In such cases, however, a skeleton pattern may be used. This is a rapid construction of wood which form and outline of the pattern to be made. This framework is filled with loam and sand, and remain the circles. Sand is removed by the sickle board. For round shape, the pattern is made into halves, which are joined with the bull or by means screw, etc. Segmental patterns. Segmental pattern is used to prepare the mold of larger circle casting. Avoid the use of solid pattern of exact size. It is similar to sweep pattern, but the difference form. Sweep pattern. The sweep pattern is give a continuous revolve motion to generate the part. The segmental part itself and the mold is prepared in the segmental part. Pattern construction should be save the material for pattern making and easy carried. The segmental pattern is mounted on the central pad mold on the positions. For after prepare of mold, the segment is moved for next positions. Pattern allowance. So pattern allowance is very important in the casting process. So pattern allowance means pattern may be made for wood or metal, and its color may not be same as that of the casting. The material of the pattern is not necessarily same as that for casting. Pattern carries a additional allowance to compensate for metal shrinkage. It carries additional allowance for machining. It carries the necessary draft to enable its easy removal from the sand mass. It carries distance allowance allows due to shape of casting is opposite to pattern. So pattern may carry additional projections called core prints to produce set or extra recesses in mold for setting. The size of the pattern never kept for same as that of the preserved casting because of the fact that during cooling the casting is subjected to various effects and hence to compensate for these effects. So corresponding allowance are given in the pattern. These various allowance into pattern can be ensured. The allowance for shrinkage, machining allowance and draft allowance, so wrapping and shake allowance for etc. So shrinkage allowance. Shrinkage allowance in practice it is found that all common cast materials shrinks a significant amount when they are cold from the molten side. The total construction means volume divided into the following parts. Liquid constructions, the construction during the period in which the temperature of the liquid metal or alloy falls from the during temperature to the liquid temperature. So construction of cooling from the liquids to the solid temperature, solidifying constructions that results thereafter until the temperature reaches the room temperature. The first two of the above are taken core by the propagating and raising, only the last one. Therefore, the solid Constructions is taken care by the pattern makers by giving a positive shrinkage allowance. This construction allowance is different for different metals. The construction allowance for different metal or alloys such as cast iron 10 mm, then brass 16 mm, then aluminum alloy 15 mm, then steel 21 mm, then etc. There is a special rule known as the pattern makes construction rule in which the shrinkage of the casting metal is added in the similar shape as the common rule. Then machining allowance. It is a positive allowance given to compensate for the amount of material that is lost in machining or finishing the casting. If this allowance is not given, the casting will become undersized after machining. The amount of this allowance depend on the size of casting. So method of machining and the degree of finish in general, however, the value varies from 3 mm to 18 mm. So typical machining allowance is very important in machining allowance. Then draft allowance. So the draft allowance is given on all the vertical surface of pattern so that its withdrawal becomes easier. The normal amount of taper on the external surfaces varies from 10 mm to 20 mm. On interior holes and rises which are smaller in size, the taper should around 60 mm. These values are greatly affected by the size of the pattern and the molding method. In machine molding, its value varies from 10 mm to 50 mm. The typical taper allowance is possible. Wrapping shake allowance. Before withdrawing the pattern, it is wrapped and thereby the size of the mold cavity increases. So actually, by wrapping, the external sections move outward, increasing the size, and internal sections move inwards, decreasing the size. The movement may be insignificant in the case of small and medium size casting, but it is significant in the case of large casting. This allowance is kept negative and hence the pattern is made smaller in dimension 0.5 to 1.0 mm. So mold wall movement allowance. Mold wall movement allowance in the sand mold occurs as a result of heat and static pressure on the surface layer of sand and the mold metal interface. The ferrous casting, it is also due to expansion due to graphically this enlargement the mold cavity depends upon the mold density and mold composition. This effect becomes more pronounced with the increase in moisture content the temperature. Gating system. So gating system refers to all these elements which are connected with the flow of molten metal from the ladle to the mold cavity. The various elements that are connected with the gating system are curing basin. So first one, runner, then extension in gate, riser, etc. So types of gating systems. So horizontal gating system, vertical gating system, bottom gating system is there. So horizontal gating system means this is used most widely the type of normally applied for various ferrous metals. Sand casting and gravity die casting of non-ferrous metal that are used for flat casting which are filled under gravity. So vertical gating system, this is applied in tall castings where high pressures and mold and die casting process are done. Top gating system, this is applied in places where the hot metal is poured from the top of the casting. It helps directional solidification of the casting from top to bottom. It only flat casting to limit the damage of the metal during the initial filing. So bottom gating system, it is used in tall casting where the molded metal enters the casting through the bottom. So middle gating system, it has the characteristics of both the top and bottom systems. In order to provide defect free casting, the gating system should make creation provisions while designing the gating system. The mold should be completely filled in the smallest time possible without having to raise the metal temperature or use high metal heats. The metal should flow smoothly into the mold without any turbulence. The turbulence metal flow tend to form dross in the mold. So unwanted materials such as sag, dross and other mold material should not be allowed to enter the mold cavity. The metal entry into the mold cavity should be properly unrolled and controlled in such a way that atmospheric air is prevented. So metal flow should be maintained in such a way that no gating or mold erosion take place. The gating system should ensure that enhanced molten metal reach the mold cavity. The gating system design should be economical and easy to implement and remove after casting. Solidifications. So solidification of pure metals. A pure metal solidifies at the constant temperature. It has a clearly defined melting point. After the temperature of the molten metal drop to its freezing point, its temperature remains constant. While the latent heat of fusion is given off, the solidification move through the molded metal, solidifying from the mold walls in toward the center. Riser. So function of risers: provide extra metal to compensate for the volumetric shrinkage, allow mold gases to escape, provide extra metal pressure on the solidifying mold to reproduce mold detail, more access. Design requirement of riser. The riser size for a sound casting riser must be lost to freeze. The ratio of volume and surface area of the riser must be greater than that of the casting. However, when this condition does not meet, the metal in the riser can be kept in liquid state by the heating externally or using exotic materials in the riser. Riser placement: the spacing of riser in the casting must be considered by effectively calculating the feeding system the distance of the riser. So riser shape: cylindrical risers are recommended for most of the casting as spherical risers, although considered as best are difficult to cast. To increase volume and surface area ratio, the bottom of the riser can shaped is riser. The riser design: the riser is a reservoir in the mold that serves as a source of liquid metal for the casting. to compensate for shrinkage during solidification. The riser must be designed to freeze after the main casting in order to satisfy its function, riser function, as described earlier. A riser is used in a sand casting mold to feed liquid metal to the casting during freezing. In order to compensate for solidification shrinkage, to function the riser must remains molten until after the casting solidifies. The rule can be used to compute size of the riser that will satisfy this requirement. The following example illustrate the calculation. The riser represents waste material that will be separated from the cast part and remolded to make subsequent casting. It is desirable for the volume of metal in the riser to be a minimum. Since the geometry of the riser is normally selected to maximum, the ratio is done to reduce the riser volume as much as possible. Riser can be designed in different forms. The design is side riser. It is attached to the side of the casting by means of small channel. A top riser is one that connected to the top surface of the casting. A riser can be open or blank. An open riser is exposed to the outside at the top surface of the coke. This has the disadvantage of allowing more heat to escape. That is the important. Then core box. Core box are compact mass of coarse sand that when placed in mold cavity, the required location with proper alignment does not allow the molten metal to occupy space for solidification in the portion and hence help to produce allowance in the casting. The environment in which the core is placed is much different more that of the mold. In fact, the core has to withstand the severe action of hot metal which completely surrounds it. Core are classified according to shape and position in the mold. There are various types of core such as horizontal core, vertical core, balance core, drop core and hanging core are also there. There are various functions of cores which are given below. Core is used to produce allowance in casting in form of internal activities. It may form a part of green sand mold. It may be deployed to improve mold surface. It may provide external under future is castings. It may be used to strengthen the mold. It may be used to from gating system of large size mold. It may be inserted to achieve deep resistance in casting. Then social casting process. This process was patented in 20th century to make higher standards hollow casting. The first centrifugal casting machine was invented by a British England is process to introduced. So working principle is it work on basic principle of centrifugal force on a rotating component. In the process, a mold is rotated about its central axis. When the molten metal is poured into it, a centrifugal force act on molten metal due to this rotation, which force the metal at the outer wall of mold. The mold rotates until the while casting solidifies. The slag oxide and other enclosures being lighter gets separate from metal and segregate toward the center. The centrifugal casting is sometimes known as centrifugal casting is process of making symmetrical round hollow sections. This process uses no cores and the symmetrical hollow section in created by pure centrifugal action. In this process, the mold rotates about horizontal or vertical axis. Mostly, the mold is rotated about horizontal axis, and the molten metal introduced from an external source. The centrifugal force acts on the molten metal, which force it at the outer wall of mold. The mold rotates until the while casting solidifies. The slag particles are higher, lighter than metal, those separated at the centrifugal part of the casting and removed by machining. The process used to make hollow pipes, tubes, hollow bush, which are axis symmetrical with a concentric hole. Semi-centrifugal casting. This process is used to cast a large size axis symmetrical object. In this process, mold is placed horizontally and rotated along the vertical axis. A core is inserted at the center, which is used to cast hollow section. When the mold rotates, the outer portion of the mold filled by purely centrifugal action, and as the liquid metal approaches toward the center, the centrifugal component decreases and gravity component increase. Thus, a core inserted center to make hollow cavity at the center. Without centrifugal force in this process, centrifugal force is used for uniform filling of axis symmetrical parts. Application: it is widely used to aircraft industries to cast rings, flanges and compressor casting. It is used for cast steam turbine bearing shell. A roller for steel rolling mill is another example of centrifugal casting. It is used in automobile industries to cast gear planks, cylindrical liners, piston ring, etc. It is used to cast bearings. This process used to cast gear component used in electronic industries. Disadvantages: provide dense metal, high mechanical properties. Investment casting. So the root of the investment casting process, the lost wax method, dates back to that at least the 4th millenniums. The pattern are prepared by injecting wax or polystyrene in the metal die. A number of patterns are attached to a central wax. Where to form assembly, the mold is prepared by surrounding the pattern with refractory slurry that can set a room temperature. The mold is then heated so that pattern melts and flow out, leaving a clean cavity behind. The mold is further hardened by heating and the molten metal is cured while it is set. When the casting is solidified, the mold is broken and the casting taken out. The basic step of the investment casting process. So, production of heat disposal wax plastic or polystyrene patterns, assembly of the pattern onto a getting system. So, investing a converting pattern, assembling with factory slurry, melting the pattern assembly to remove the pattern material. firing the mold to remove the lost tracks of the pattern material during. Then ceramic shell investment casting process. The basic difference in investment casting is that in the investment casting the wax pattern is impaired in a refractory aggregate before dewaxing, thus is ceramic shell investment casting. A ceramic shell is built around to assembly by repeatedly dipping pattern into slurry. After the ceramic shell is completed, the entire assembly is placed into an flash fire furnace and high temperature. The shell is heated to above 982 degrees Celsius. So advantages: excellent surface finish, tight dimensional tolerance, machining can be reduced or completely eliminated. The process, so the mold like a permanent mold manufacturing process. The first step in die casting is the production of the mold. The mold must be accurately created as two hells that can be opened and closed for removal of the metal casting. Similar to the basic permanent mold casting process, the mold for die casting is commonly machined from steel and contain all the components of the gating system. So multi-cavity die are employed in manufacturing industry to produce several casting with each cycle. In die casting production steps, the mold is designed so that its mass is far greater than that of the casting. Typically, the mold will have 1,000 times the mass of the metal casting. So a pound part will record a mold making due to the extreme pressure and the continuous expose the thermal gradients from mold metals. So die casting machines. In addition to the opening and closing of the mold of prepare for the remove casting, it is very important that there is a engaged force can be applied to hold the two hulls of the mold together. During the injection of the molten metal, flow of molten metal under such pressure will create a treatments force acting to separate the die hulls during the process. Then cupola furnace. Cupola furnace is melting device used to melt cast iron and some bronze, and it is used in foundries. The cupola can be made of any size, and the size of the cupola is measured in diameter, which range from 1.5 to 13 feet. The shape of the cupola is cylindrical and the equipment is arranged in the vertical fitted with door which is swing down and out drop bottom. The top is open or fitted with a cap to escape gases or rain entering. The cupola may be fitted with a gap to control emission of gases and to pull the gas into the device. To cool the gases and remove all the particulate matter. The cupola shell is made of steel and has a refractory brick and plastic refractory wetting material lining. The clay and sand mixture is used as a bottom line, and the lining temperature the coal can be mixed with the clay lining. So when it heats up the coal, the bound become friable, the make opening up to the two holes easy. So So the construction of the cupola furnace. Cupola furnace construction in the form of the hollow cylindrical vertical steel shell, and it is lined from inside with the refractory materials. This furnace is generally supported on 4 cast iron legs mounted on the concrete base. The bottom of the furnace is closed by 2 cast iron doors. To the bed plate of the furnace, wind box cast iron encircles of the outside of the furnace bottom. The box is connected to the furnace blower pipe known as the ballast pipe, air which supplies the oxygen necessary to burn the fuel forced through the cupola by a blower. Working. Basically, the operation of cupola furnace consists of following steps. After the building, the cupola makes sure it is dug completely before creating into fire. Any slag around the fuse runs need to be cleaned properly. So after the changed furnace, it is allowed to remain such for about 1 hour. This process goes in charge slowly, gets heated up as their blast in kept certain time, and because of this the iron hits sockets. The rate of charging is equal to the rate of melting. The furnace is kept full throughout the heat, closing feeding of charge the air plastic stop. When no more melting is required, the bottom plate swing to open when the prop is removed. The deposited slag is being removed. The cupola runs continuously and melting period does not exceed 4 hours in most of the time, but can be operated for more than 10 hours. Advantages: so low cost of construction, low cost of maintenance, low cost of operations. Very skilled operators are not required. Simple in construction, simple in operations. Melting consumption can be controlled. Small floor area is required. Disadvantages: with a long list advantages, cupola furnace also comes with a few of limitations or disadvantages, and they are listed below. It is sometimes difficult to maintain the temperature in cupola furnace. Metal elements are converted to their oxides, which are not suitable for casting. Applications. So cupola furnace is used widely as a melting unit for cast iron. Some of the characteristics that makes the cupola furnace are primary method used in melting irons in the foundries. Some of them are cupola furnace is the only method which is continuous while operations. The melting rate of cupola furnace is high. It is easy to operate. So operating cost in use of cupola furnace is comparatively very low to other method for this process.